Is it playing now? Is it working now? Okay. Whew. Awesome. So, what I was saying was how weird 2020 has been so far. It's been crazy. And this weekend just added more stuff to that. But thank you for letting me know about the audio. What would happen if you did not do the review, but you did all the work pages? So like you didn't do this assignment and you did the others? Well, hopefully it brings you above that 80% threshold. Right? That's what matters. All right, so section J, we got logs. It's just a mixture of we have a bunch of exponential equations. Are there any of these in particular that you'd like to see me go over? There's only an 8-second delay. Number 3. Use the properties of logs to find... Okay, so we have log base 9 of 4 over 243. Given that log 9 is 12 is A, log 9 8 is B, and log 9 5 is C. Okay, so in these types of problems, what we want to do is we want to break up this statement into log A 12, log 9 12, log 9 8, and log 9 5. We need to break it up into those. So, part of the way that we can break it up is going to be by factoring this. So this is going to be log base 9 of 4 over 3 times 27. Even if we're done reviewing this, are you going to still do the streams for the rest of the week? No, today's actually going to be the last stream, but I am still available for any question that you may possibly have on Discord. So just go ahead and shoot me the questions, and I'm more than happy to help. So I'm still available to help. Then the 27, that can be factored a little bit. So we have log base 9 of, and then it's 4 over 3 times 27. Oh, whoops, that should be 9. Now, the reason why I have been breaking this down a bit is because, actually, I'm sorry, that's not 3 times 27, it's 9 times 27. I was like breaking it apart 2 stages in advance, and I had 3 on the brain. Okay, so 243 is 9 times 27, and then I break that 27 into 3 times 9. Now, the goal, like I said, is I want these to be log base 9 of 12, log base 9 of 8, and log base 9 of 5. So right now, if I wanted to rearrange this, into 9 times 9 times 3, well, I do know what log base 9 of 9 is. That's 1. So already I know that these can get simplified. But I don't know about the 4, and I don't know about the 3. So I need to think, okay, is there any way I could transform that 4 into a 12, an 8, or a 5? So I could do 12. If I did 12, it would be 3 over 3. I would get 4 times 3 is 12, and then 3 times 3 is 9. Both of those numbers are nice because the log base 9 of 12, well, I know that simplifies. And then this 3, that turns into a 9. I know that simplifies. So it looks like that one's going to work. But let's think about the 8. Let's say if I wanted to turn that into an 8. So I would multiply this by 2, the 4, Now if I multiplied that by 2, that would give me an 8, which would work. But then down here in the bottom, if I multiplied that by 2, that would give me a 6. And there's nothing here, log base 9 of 6, that's going to help me and simplify. So I don't want to go that route. So I want to make that into a 12. So I'm going to multiply by 3, multiply by 3. And so now I'm going to get log base 9 of 12 over 9 times 9 times 9. So now they're all values that I know how to break this up. Yeah, today, you're going to see after this stream, the assignment's going to be available for you to post it. So now I could break this into log base 9 of 12. Now it's positive because it's on top. Now these are on the bottom, so they're all going to have minuses. So minus log base 9 of 9 minus log base 9 of 9 minus log base 9 of 9. So this log base 9 of 12 is A, and then those 3, 1 minus 1 minus 1, so that should be A minus 3. And so that right there is going to be my answer. Any other ones in section J? Welcome. Number 9. So I get 10 log of x over 10 to the negative 12. And this is going to equal 150. So I want to solve for x. So the first thing I can do is divide by 10. We want to isolate the log because that's the only way I'd be able to get rid of the log. And then, so that's 15. Then, to get rid of the log, we have to think of the base. So since it's just log, there's no base written there. I know it's log base 10. So base 10, we'll get rid of it. So I'm converting it into an exponential equation. And now, for this x, I have a 10 to the negative 12 in the denominator, so I can multiply by 10 to the negative 12. And so, same bases, add the exponents. 15 plus negative 12 gives me 10 to the third, or 1,000. Do you have any questions on that one, Maria? Cool. All right, other ones. Section J. Okay. Let's move on to part K. So part K is the transformation of functions. So the first piece, number 7. So on number 7, it's e to the 2x equals e to the x plus 6. Now, for this piece right here, there is something that we learned. It was called U-Substitution. So this looks like a quadratic type function. It's just one of those types of things. As you do more problems, you start recognizing it a little bit more. So like right off the bat, like just being able to be like, bam, I know what that looks like. It's just not, it's something that we develop. So if I said u equals e to the x, well, this will turn into u squared equals u plus 6. This here is a quadratic type equation. So I can subtract those. Now, because it's quadratic, all the rules of a quadratic function now apply. So this will factor. This will factor into u minus 3 and u plus 2. Now I can set each of these equal to 0. So u minus 3 equals 0 and u plus 2 equals 0. And then now this, u minus 3 equals 0, I can add 3. And then this one, it's equals negative 2. Now we weren't solving for u, we were solving for e to the x, right? So we have to resubstitute that in. So the e to the x equals 3 and e to the x equals negative 2. Now to get rid of the base e, the log base e is what gets rid of it. Log base e is the same as ln. So we do ln to both sides. So that cancels out. So I get x equals ln 3. Now this is impossible. You can't have a negative or 0 inside of a log. So we ignore it. And so our only answer is going to be x equals ln 3. You're welcome. Any others for section J? Okay, let's move on to K. So in part K, we just have to remember the transformation of functions. Basically, if you remember that we have to first think of what the parent graph looks like. So for example, on 1, it's quadratic since it says square. 2, it's quadratic or a parabola because it says square. 3, that's a rational function. Remember, a rational function has the asymptotes and then the graph does that. Right? So we have to memorize the shape, but then the transformation's all the same. So there's an h and it shifts horizontally, and there's a k that's going to have it shift vertically. So for example, on number 4, if I have f of x equals the square root of x plus 5 minus 6, I have a horizontal shift of negative 5, and then I have a vertical shift of negative 6. And so my graph normally starts at 0, 0, but it's going to shift over into the negative 5 spaces, and then down 6 spaces, and then that's the shape of my rational function. Any comments or questions on 1 through 6 on that? Okay. Any questions on... Okay, so we do have a question on the sine and cosine. That's what I was going to ask next. Any questions on sine or cosine or tangent? So graphing trig functions. So on number 8, we'll unpack it. So I have negative tangent of 2x plus pi halves minus 1. So now there's a few things we got to pay attention to. The first, it's tangent. So I need to think to myself, parent graph dot asymptote dot, and then that's the shape. That's what it's going to look like. But this negative, that's a reflection. So that's going to be a reflection over the x-axis. So this is going to reflect down, and this is going to reflect up. So it's actually going to be the blue part. So the red was the parent graph. That negative caused that reflection, which is why they flipped. I know it's like backwards because of the camera. My apologies. Now I have a period shift. I have a horizontal shift, and I have a vertical shift. So we need to recognize those when we go to plot them and graph them. So I need to take this 2x plus pi halves, and I put that, because I need to find what these values are. Like, I don't know what that value is. I don't know what that value is. I don't know what that value is. I don't know those x values. I need to know what they are, because then once I know where the x values are, I can place them on my graph. So we're going to take whatever's inside that tangent and put that between 0 and pi. Now we do 0 and pi because it's tangent. So we're going to subtract pi halves from everything. So I'm going to get negative pi halves is less than or equal to 2x, which is less than or equal to pi halves. And then we're going to divide everything by 2. So I get negative pi fourths is less than or equal to x, which is less than or equal to pi fourths. Any questions on that piece so far? Now, if it was sine or cosine, you would put it between 0 and 2 pi. So I did 0 and pi because it's tangent. If it was sine or cosine, it would be between 0 and 2 pi, because the natural period of sine and cosine is 0 and 2 pi. The natural period of tangent is between 0 and pi. All right. So now I need to find what those x values are. So I'm going to take those values. That's my starting value, negative pi fourths, and my ending value is positive pi fourths. And to find the other values, we use the midpoint, or the concept of the middle value. And to find the middle value, it's just the in between the two values. And we can find that mathematically by adding the two values and then dividing by 2. So you take the two ends, you add them together, and you divide that by 2. And you can do that with anything, and you can find the middle of it. Let's give an example. Between 10 and 20, we know is 15. But if I add 10 and 20, 10 plus 20, you get 30. Divide by 2, you get 15. So we can find the middle of anything by adding the ends together and divided by 2. So adding those together and divided by 2, I get 0. Now, one thing, a mnemonic that I had you guys memorize is DAD. He helps us graph a tangent. And that just stands for dot, asymptote, dot. So it just helps us recognize what are dots and what are asymptotes. So placing that on the graph, looks like everything is by pi fourths. So I'm just going to say every one of these little tick marks is going to be a pi fourth. So that's negative pi fourths, and that's positive pi fourths. My vertical shift, you can't forget about that. So that's a down one space. And so that little dotted line there, I just imagine that to be my center line. So I'm just moving that down one space, and I'm going to draw everything around that new line. And so now I know that it's going to be dot at negative pi fourths, because we said it's a dot. Then it's going to be an asymptote at 0. And then at positive pi fourths, it's going to be another dot. And remember, I said I'm drawing that around the center line. And so then for here, just drawing in the graph, we look at my parent pattern that I created. So that's going to go down this way. And then for that one, that's going to go up this way. And they're going to hug the asymptotes. So this right here is a picture of the graph. And in class, I said for tangent, we're not going to really focus on the domain of that. So I'm going to be consistent with that. Don't worry about the domain for tangent. That's something that we're going to focus a little bit more on in pre-calculus, because it's a major theme. So we really, really hit finding domain and range and stuff like that in pre-calculus on everything that we do. So yeah, so we don't have to worry about the domain part. The range is negative infinity to positive infinity. But for the domain, don't worry about that for tangent. Just yet. Any other questions with that, Maria? Does anyone else... You're welcome. Does anyone else have any other questions on part K? Okay. Now let's do part L. I am going to do number 2. So number 2, we have x to the 7th minus 3x to the 6th minus 9x to the 5th plus 27x to the 4th. All right. So for this one, it's asking us to graph it and then find the end behavior, zeros, and the y-intercept, because labeling those 3 things are pretty essential to when we graph it. And if we have those 3 things there, it's going to be much easier for us to be able to graph it. Okay. So when we factor a polynomial, we need to use something called the rational zeros theorem. And that's the whole, and I'm sure I say it, p's over q's. That's going to like ring something in our brain. Oh yeah, I remember p's over q's kind of. So we're going to be using the p's over q's to be able to help us with that. The only difference is the first thing we should always do when it comes to factoring is to factor out what's in common. And so this x to the 4th, we need to factor out that x to the 4th. So factoring that out, I'm going to get x to the 3rd minus 3x squared, and then minus 9x, and then plus 27. So I factored out that x to the 4th. Now that we factored that, I can do my p's over q's with that part there. And so your p's over q's is you take the factors of this number, so 1, 3, 9, and 27. So you always take the factors of the constant and you divide it by the factors of your leading coefficient. So your leading coefficient in this case is right here, and it's 1. So what you're going to do is you're going to take every single combination of that top number over the bottom number. So 1 over 1, 3 over 1, 9 over 1, and 27 over 1. Now each of these should be plus or minus. I'm just saving time. But they're all plus or minus 1, plus or minus 3, etc., etc. So these, we call these possible zeros. Now they're possibilities because we don't know if they're actually zeros or not. But if there are zeros, bam, those are what they have to be. So we call those our possible zeros. So now we go through and we test them. And the way that we test it is by division. Dividing tells us, and we know that if we divide something and our remainder is 0, we know that it divides evenly. Now looking at this pattern here, I'm going to use synthetic division because it's a little quicker. If you notice, it goes from 1, 3, 9, and then 27. It seems everything is getting multiplied by 3. That tells me 3 right here is probably going to be a good one. Now it could be negative 3, it could be positive 3, I don't know. But let's just start with positive 3 to see how that's going to work out. So we take the 3, we put it in the box, and then we write out the coefficients. Now if, hypothetically, let's say that x squared wasn't there and it didn't say negative 3x squared, we have to put a placeholder. So we would put a 0 in that place if there wasn't an x squared. Sometimes we forget that, but we got to pay attention and make sure that all those things are there. So then we're going to add straight down and multiply because all we're doing is dividing now. Add straight down, multiply, 0 times 3 is 0. Add straight down and then multiply, negative 9 times 3 is negative 27. Add straight down, you get 0. Now, you know it divides evenly when your remainder is 0. My remainder is 0. Yay, that is one that we want. So I could actually write this now in a little bit more factored form. We know that this 0 represents a factor of my polynomial. So I'm going to get x to the 4th. Then this 0 right here, that 3, is x minus 3, because it's always x minus your 0. And then I have this remainder, constant, x, and then x squared. So I have 1x squared, no x, and then minus 9. So I basically took this and factored it a little bit more into this. Now, if we're able to factor more, you need to factor more. Now, you know you're typically done with factoring if none of these other possible zeros can reduce into it anymore, or it's linear. Well, that's not linear, so I technically could use more, but it's also quadratic. I know other ways to factor a quadratic equation. So this is a difference of squares, and so that will factor into x minus 3 and x plus 3. So now it's completely factored. And what I have now is going to be x to the fourth times x minus 3 squared, since I have two of them, 1, 2, and then x plus 3. So now we need to just find those three pieces of information from the polynomial. Y-intercept, we look at the original. Plug in 0, plug in 0, plug in 0, plug in 0. So if I plug in 0 for x, my y value is going to be 0. So my y-intercept is 0, 0. Then my end behavior. Now for the end behavior, we can also look at our unfactored polynomial. We look at the leading term. It's positive, and the degree is odd. That's 7, that's our degree, that's odd. So when it's positive and odd, the end behavior is going to look like that. That tells me it's going to start here and end up there. And then now the last piece is the zeros. So my zeros, if I set each factor equal to 0, I get 0, I get positive 3, and I get negative 3. Now, when I sketch a graph, we need to know the multiplicity of my zeros. The multiplicity tells us how the graph is interacting with those zeros. It could either just go to the 0 and cross through it, or it can go to the 0 and then bounce back the way it came. And it could do like this, or it can do this. It can come in from the top, boop, and then go back the way it came. If it's odd, crosses through. If it's even, it's going to bounce. So for 0, because it says x to the fourth, I know I have 4 of them. So it's multiplicity 4. It's even, so it's going to bounce. For number 3, it's going to be multiplicity 2, because it says squared. It's even, so it's going to bounce. And then for negative 3, because it's technically x plus 1 to the third, my multiplicity is going to be 1. And because it's odd, it's going to cross. So now I can start putting all this stuff here on the graph. My y-intercept is 0, 0. I'll do blue. Why not? My zeros are also 0, 3, and negative 3. And then my end behavior, I'll do it in this light color here. It starts down there, and it's going to end up there. So I know where I need to start and then where I need to end up. So let's draw it. So we start from down there. We go to our 0 at negative 3. At negative 3, the multiplicity is 1, so it's going to cross through it. Now it always wants to go back to the next 0. So at 0, my multiplicity is even. It's 4, so it's going to bounce. Always wants to go back to the 0. At 3, my multiplicity 2, so it's going to bounce. And then it's going to go to where the end behavior is. Now this is just a rough sketch of what that is. And so there's the sketch. And there's my zeros. Any questions on any of those elements there? Okay. So let's finish up with some law of sines and cosines. So for this one down here, this triangle, that's 62, that's 20, and that's 40. Let's just label it. I can say that's A, B, and C because that'll make things easier. You can label it however you want. You could say C, B, A, I don't know. Doesn't matter. We just have to be consistent. And then this is side C, and this is side B. Now, based on the information, I have Angle, angle, side. Angle, angle, side is law of sines. Ah, there you go. No. Why aren't you working? There you go. Okay. So law of sines. Now, law of sines, I have, if you remember, that's the A over sine A equals B over sine B equals C over sine C. So that's the law, and I just need to find ratios and be able to set those ratios equal to each other to find what I need to find. So in this instance, I first need to find angle C, and I can do that because all the angles of a triangle need to add up to 180. So 180 minus those two, that's going to be 98 degrees. So I know that this is going to be 98 degrees. Now to find B and C. So to find B, I can say B over sine B equals, and I have my A ratios. So I have A and the angle A. So side A and angle A. So then I can say A over sine A. Now my angle B, I should have written it in. Come on, eraser. What is that nonsense? Is that supposed to be color too? Is that why? Yeah. Okay. So my sine B is actually going to be 20. So to get B by itself, multiply both sides by sine 20. And so you're going to get B equals 40 sine 20 over sine 62. And then do the same thing with C. So C over sine C equals, and I can do the A ratio again, so A over sine A. Get C by itself by multiplying both sides by sine 98, and then you get your value. I know it says find the area. We don't need to worry about finding the area with these types of triangles. That is going to be more of a pre-calc thing. I thought we were going to have more time in this class to go over that, but we didn't, so it's something that I did skip. So we don't have to worry about that piece. For number 1, it is the law of sines, and then as a hint, because number 2, it's side angle side, that's going to be the law of cosines. Any last questions before we wrap it up here? Just know, though, that I will have the assignment posted for you guys to be able to upload everything today. And so you guys will have today, you guys will have Tuesday and Wednesday. Yeah, and then I upload all the grades on Thursday. So all your grades will be in. If you completed all the assignments and uploaded them, there's your 10% bump. If there are any disputes, if I make an accident or I miss something, please just let me know and I can go through and fix it. Yeah. I'm going to do my best to make it reflect in Aries before I submit it to remove that ambiguity, but I'm going to have to fiddle with a bunch of things to get that figured out. Awesome. Well, thanks, guys. Have a good one. Stay safe. Stay healthy. I really appreciate, you guys showing up to these streams and stuff. For those that are enrolled in summer school, an update on that's going to come out on Wednesday or Thursday. But I truly appreciate you guys joining for this. It was fun. And I wish I could give you guys all high fives in person and we could celebrate the end of the year together. That would have been awesome. The circumstances didn't enable us to be able to do that. So I appreciate you guys. Thank you. And just let me know if you guys have any other questions as you guys work through this in Discord. Have a good one.